So the topic today is the title I chose, Releasing the Captives and Historical Records. I'm actually paraphrasing something that Elder Kapishka said during the on-site visit that our executive directors paid us about 6 months ago. I don't know if you remember, but when Elder Kapishka talked, we were over in J here in Orem, building J. He alluded to releasing the captives and what he called church records. And I think by that he generally meant historical records. And I really latched onto that. I liked that, the way he worded that. And you think of all these people who were locked up in these records because we can't find them. And we'll talk about, today we're going to talk about handwriting recognition and just information extraction in general, automated information extraction. And the way we're going to structure this is that I'm going to take the first 25 to 30 minutes to go through some slides, and I'll try to go through these quickly. And then the second half of the presentation, we're going to have an open forum with the experts who are here. So I'm the team manager, and if you ask me any detailed questions, I'll probably claim ignorance. But we've got Pat Schoen and Heath Nielsen, Christian Hargraves, Alan Canaday, and Randy Johnson here today with us. Did I miss anyone? For some of the folks who are actually down in the trenches, among others too. It's not all within the research team that this effort is going on. Anyway, I want to start out with a little game here. What I've found is that many of us, as we do our family history, we don't encounter the full variety of records that Family Search has. And it was surprising to me as I started pulling random samples out of DAS and just what types of records are out there that we have that are not indexed today. So the game today is going to be name that unindexed record. And so what I'd like you to do is try to guess what type of record this is and what collection it may be from. Somebody's back pocket. That's not too far from the truth, actually, on this one. A receipt?
Legal document.
Legal document. What language is it in?
English.
English. So this is actually from...
1800s.
Yep, 1800s is right. And actually, something in someone's back pocket's not too far off. So sometimes these documents got folded and carried around, and so that's why it's kind of got this odd shape to it. So these are from probate records. By show of hands, who are familiar with probate records, who've used those actually? Just a few of us. So these are really cool. There's a lot of good information in these, but they're not very indexing friendly because they're not very uniform. And this one, like as Pat mentioned, I think is actually a receipt associated with a probate. Okay, next one. I know it's kind of hard to see this, but any idea? First of all, what language is this in? Spanish is correct. Any idea? I don't know if anyone can actually read that. So there's a little clue here. It says Cementerio General. So these are cemetery records from Chile. And none of these are indexed, by the way, that I'm showing you here. Okay. How about this one? Somebody should get this here. Italian, yeah. What kind of record is this? Civil registry. Specifically, it's a death. Yep, this is civil registration. By the way, we have over 150 million of these images from Italy, and only just a small handful of them are indexed so far. Now it gets a little harder. Language? Anyone guess the language there?
Russia.
Yeah, Russia. Right, it is Russian. This is from Russia. I've never even heard of this type of record before, a confession list, whatever that is. But it looks to me like it's something that's kind of tabular, like a tax record, where you got a lot of numbers and names written down. This one threw me. Language? No one's going to guess it. So it's Indonesian. I didn't even know we had records from Indonesia, but apparently we've got a lot of them. This one, can you guess the language on it? It is Portuguese, that's correct. This is actually from Portugal. So these are Catholic Church marriages from Portugal, not indexed again. And you can probably see why too, that's a pretty challenging script. How about this one? You're Cambodian, Thai, I think you're honing in on it. Sri Lanka, I don't know what language that actually is. Tamil? Did you even know, did anyone know we had this stuff in our collections, by the way? Anybody? Okay. How about, somebody will get this one. This is Chinese. What collection do you think it comes from? The Jiapu, Chinese genealogies. This is a particularly busy one too. They don't all look this packed with information. But we've got, I want to say, 21 million images of these. Very few indexed again. Language? We're almost done here, by the way. Language?
English.
I heard German.
It's English.
Pat already knows this one. So this is English, and it's actually not even Old English. This is modern English. This record was from 1630. And no one's going to guess what it is because you can barely read it, unless you're Pat Schoen. This is a court record. So this is an arraignment in a court setting in 1660, I think. And that guy right there is my ancestor. So this record's pretty important to me, but this record is not indexed. And this, I'll tell you, this was a bear to find. I had to know what I was, first of all, some reason to suspect he would be in there, to even go looking in these records because it's not indexed, but it was a real bear to find for me. I had to lean on Pat with some of his paleography skills to help me out there. So, but this record, by the way, just the reason that I was interested in it is my ancestor was a Quaker. This Henry Morey was a Quaker. And I read in some other documents that he had been imprisoned for refusing to take the oath of allegiance, along with some other Quakers in his community. So, but the point of this, me showing this, is that no doubt your ancestors are in some of these documents, including, in all likelihood, some ancestors you don't know about, and you never will know about them until they get indexed. So we've got a growing gap. I kind of want to throw the problem out here that, first of all, these records are not the type that you're probably accustomed to seeing. The census, for example, when the census comes out, we knock that thing out really fast with indexers. So that one's really not the problem for us. The gap that's occurring between image digitization and indexing is mostly, but not exclusively, mostly affecting the non-English records. And as a growing church, we're growing in non-English communities very quickly. And also the technology levels are graduating to the point now that they can start to do online research in these areas, but in many places they just have nothing to go off of. I was talking to someone the other day about the Philippines, for example. If you're a member in the Philippines and you have access to technology, you have no reason to go on the Family Search site to search for records, because it's such a long shot that you're going to find one of your ancestors. You guys have heard probably the 2 to 20 goal of records, the records department going from 2 to 20% coverage. What that means is that they want to get to a point that where for our top countries where the church is located, that you can just pull an ancestor's name out of the air, and 20% of the time you'll be able to find a record for them on the site. By comparison, in the US, they calculate we're about in the 40+% range of our coverage. But in many of these countries, it's like less than 1% hit rate. And so if you're a member there, you have no reason to go on the Family Search site because it's such a long shot that you're going to find someone there. Another reason the gap is growing is that, well, first of all, let me back up. The reason that non-English records are important is because most of our indexers are right here in what we sometimes call the Jello Belt. And they don't really like to index non-English records because they're hard. In fact, they don't even like to index hard English records because they're hard. So they end up picking, a lot of times, some of the stuff that's easiest but also lower priority for us. So we've got this gap that's growing. And we also have archaic scripts that are in these documents, like that other one that I just showed you. That actually was English, although it doesn't look like it. It wasn't Welsh, that was English, yep. By the way, all cursive script is becoming archaic when you look at the youngest generation now. So it's getting harder for people to read this stuff. And there's another reason I like to talk about, so now what I'd like to lay out is a case for why we're doing automation when it comes to records. And I think this is probably obvious to most of you, but there's another issue that most of us are not aware of. And this is what we call the long tail issue. When you look at the types of projects that we index, like the census, or any project for which there's an indexing project today, they tend to be more uniform records that are consistent and structured. Those lend themselves to an indexing project because you can write instructions for something that's structured. You don't have to deal with and as it is, by the way, it's really hard to create instructions for these. It's costly for us. But the downside of that is that we're really only indexing the records that are pretty uniform. But if you look at, and this dotted line kind of represents some theoretical line where we say this is not uniform enough, we're not going to create an indexing project for it. So on this side of that line, you got these records like that probate record I just showed you. There's just a hodgepodge of stuff that's been thrown out there. We can't really create instructions for it, so we don't index it. But it could very well be that the area under the curve of this long tail is actually far greater than the area under the first part of the curve here of our structured records. We don't know until we index them. So that we really need machines to start helping us with this task because these records are not uniform. Switching gears here a bit, I know a lot of you have heard probably some of the progress that's been made with handwriting recognition recently, and I wanted to tell a story about this graph here. So this, first of all, this graph doesn't go back. This shows our word accuracy on a test set that Pat has created and others have created on this in the records and partner division that represents a broad swath of U.S. wills from anywhere from the 1500s on forward.
No, it's from the Pilgrims.
Oh, from the Pilgrims?
From the 1620s, yeah.
Yeah, although the bulk of it, we'll say, is in the 1800s, to be fair. But, I mean, it's a pretty broad swath of documents and authors. There are thousands of authors in these documents. And you see that the current word accuracy that Pat and company have achieved is 88%. Now, word accuracy is, I'll demo this in just a second, but word accuracy is a stronger measurement than what you're used to probably with talking about OCR, where they talk about character accuracy. Word accuracy meant you get credit if the word is completely right. You get no credit if it's wrong at all, if you miss any character. So when we talk about 88%, that's really good. That means that 88% of the words in this document, and I'll show you an example in a minute, are correct. It doesn't mean that 18% are totally wrong. But you see the improvement over time. This red line represents what the goal has been, and the blue line represents the progress over time.
What's the time period? Is that just this year?
This is through,
August last year.
It's from August of last year through March of this year.
But you can even go back further to.
Yeah, and so this big uptick is that we teamed up with Bill Barrett and some of his grad students at BYU, and they, through some technology sharing, we'll get to this in a minute, I won't get into details. But what I really want to tell the story of is there's another big uptick that you don't see that's off the graph here. So a year ago was it this November?
Yeah, October.
So October timeframe. So go back a year from that. So Pat Schoen, who's sitting here next to me, by the way, and myself and Jake Gehring. Jake since moved on from Family Search, but many of you knew him. He's was from the records division. We were sitting over in Mama Chu's over at the mouth of Provo Canyon here, and so Pat had been working on an OCR engine for newspapers, and along the way he said, "Hey, I think this might work for handwriting too. The same techniques would work for handwriting if we got some training data." So we were able to create some training data, and Pat ran it, and we've got the first results. that day at Mama Chew's. And what were the numbers, Pat?
So I got the first results, they're 8%.
8% word accuracy. So, and we were excited about that because we were on the board. But so seriously, I mean, it was exciting. Jake was maybe less than excited.
Yeah.
But
These numbers can go to negative infinity, so 8%.
yeah, 8% is not terrible. But what's remarkable to me, and I think is truly a miracle, is that within a year, Pat and company we're above the 80% mark, word accuracy, and since then too, up to 88%. And this is really good. I'll show you an example here. In fact, it's right now. Oops, hang on just a second. Sorry about that. So Christian Hargraves, Richard Chesworth, and a few others put together a little prototype that I'm going to use. Merlin. Yeah, I appreciate you guys doing this. Sorry guys, I'm having trouble getting the demo. I'm going to close that for a second. Okay. It's coming. There we go. So, so the guys I just mentioned took, let me back up. So Pat ran that handwriting recognition on 2 counties from Pennsylvania that were of interest to us, and him personally too, and others. So these are wills. They're all written in cursive. Again, I mentioned they're anywhere from ranging from the 1500s onwards, although most of these are in the 17 and 1800s. And so the guys I just mentioned then took the output that Pat from the handwriting recognition and actually put a search front end on it, and that's what I'm going to demo. The reason I wanted to demo in this front end is it just shows a lot better than showing you like the raw text files. So what I want to show you is that I searched for Maury, for example, and it turns out there actually are some Maury's in some of these wills. And I don't know why you're not getting the edge of my screen there. Let's see if I can fix that.
That's better, you can do it right there.
There we go. So, you know, I learned there's actually Maury's in this county in Pennsylvania. And if you look at this transcript, it's really good. So here's the will of Jacob Maury. And I go back to that prototype. There's Jacob Maury. I got it right. Now it's not 100%. As we mentioned, it's probably this one's probably in the 88% range, I guess.
This would have been 83. This is right after we did the 80.
Oh, was it right? So every one of these counts as a mistake where you see like WIL and then there's this keyboard symbol. That actually counts against us, but you can actually still figure out what it says. So one of the things that we've been talking about is doing sort of a fuzzy search on these documents too, that helps to mitigate some of the errors on there. But even with the errors, you can see this is really good. There's some really good progress here. And I really feel like the Lord has blessed this effort. What's that? Oh, do you want to do that one?
Yeah. He'd be the person.
Keyboard will work here too. Anyone recognize this character? Of course you don't if you don't see it. It's Emma Hale's father, yep. So this was one of the first use cases. Once Pat had this transcript, he and Heath were asking, well, who can we test this on? And I guess put their heads together and remembered that Isaac Hale was from Susquehanna County, and sure enough, they found him right off the bat. So we're excited about that. Now, getting back to the presentation.
You got a question?
Yeah, Michael.
There's word accuracy and then there's like name accuracy. How does that compare? Are they proportional?
You want me to answer that?
Yeah, go for it, Pat.
So the question was, there's word accuracy and then there's, I'll call it entity accuracy.
Okay.
And we actually have done an entity score. And so it depends on what kind of entity is. And so if we say, well, how well are you doing on people names? It's getting 75% of people names. I think it's on the per word of people names. There are other fields like dates, and I think it was getting in the 93 or 95 or something like that of that. So we actually have it for all the entity classes that we care about to be able to move forward to automatic indexing.
So in general, higher word accuracy does indicate those are improving also?
Yes, but interesting, like you point out, the names. One of the hard parts about the names is if I were to start saying words like, he is from, and then I could say, what's the next word? You might guess the, or, there's a certain set of words you would guess after that. If I started spelling out the names, the letters of a word, of a name, you're like, I don't know what it could be, because it could be all sorts of things. And so names are a little bit harder than other kinds of generic words.
So we'll definitely leave some time for questions here. Let me just, if I can just go through this really quick. So what is our strategic objective with this? We're under no illusion that we're going to get to 100% of everything we've got for a number of reasons. First of all, there are languages that aren't a priority for us right now, and as a church. And for every additional language and script, there's some investment required to create training data. But also there's some documents that are just really hard, that are damaged, that are hard for a person to read, much less a machine. So our current strategic objective is what we've been calling the 80-80-80 goal, and that is 80% or better word transcription accuracy on at least 80% of our holdings, and at a cost of no more than 80 cents per 1,000 images, and that's an infrastructure cost that we're referring to. And we haven't set a time frame on this goal yet, but I view it kind of a little bit like the man on the moon goal, because it's a big lofty goal, but we do feel like it's technically possible, especially with the help of the Lord. A lot of people, another question I get a lot is, why are we doing this at all? I mean, as Family Search, why are we doing handwriting recognition? Isn't that something that Google is doing? And the answer is yes, with a lot of caveats. But the real answer is we're not doing it on our own, first of all. As I mentioned, we're partnered with BYU, but a lot of this, the software behind this is actually open source, and it comes from published research. And we've actually kind of got some scars by, we initially did go out to look for third-party solutions for handwriting recognition, and it's really disappointing what's out there, both in terms of their accuracy, but also the cost is just way through the roof for an organization like ours. But there's another thing too that I've learned coming from an engineering background and coming into this space that's really surprised me, is that there's a different equation at play here when it comes to machine learning technologies, which is what this is. So I've always assumed that, you go and you find a best-of-breed software solution, and it's the software that's the secret sauce. Well, the big secret about machine learning is it's not the code, it's the data. And this is really proving to be true. In fact, the code, you'd probably be shocked at how little code as a research team we've actually written. Most of the code that has been written is around, I think, edge case stuff, but it's the core code itself is coming off the shelf from open source libraries, and research papers, as I mentioned. The real secret sauce is the data when it comes to machine learning. And question, who has the data in the industry? Well, we do. In fact, what really has surprised me is that we've had some serious research groups like the READ Consortium in the EU have come to us asking for training data. And these are the serious, quote unquote, serious guys working on handwriting recognition. So we've got these serious entities turning to us asking for training data, and finally the light bulb kind of went on and said, oh, we've got the data, we've got the solution. And it's really proven. I think one dramatic example of this is the OCR results, which I don't have in this slide. But Pat, what's your latest on the OCR accuracy for the British papers?
For the British?
Yeah.
95.5%.
So Pat's at 95.5% on British newspapers for OCR, and the best of breed.
British was about 82.
So the most expensive, the most well-respected commercial solution is 82% for that. And it's not because we're technically more awesome than they are. In fact, they put millions into that solution. The real secret is that we've trained it on data that's specific to the data that we want to run it on, whereas they're trying to be a general solution for everyone. So as an organization, we have unparalleled access to training data and annotation of that data, which is really important for machine learning. We have the indexing volunteers, and if we can redirect them a bit to where they're actually helping create training data directly. And the other part of this flywheel is that we believe that we can use automation to make their experience better. So it's not a matter of just replacing the indexers and machines replacing people. It's a matter of achieving this kind of flywheel effect where both are moving in harmony. And I won't get into this, but the Infinity team, this is part of their charter, is to actually figure out how do we create this flywheel. And just to close out the slideshow part of this is I want to talk a little bit about beyond transcription. So transcription is just writing, basically transcribing what's in the image. To actually get the information out is an equally hard, if not harder, problem in some cases. And you're all familiar with the robo-keyed obituaries that are already on the site. This has been one success story. And this is a very high level of some of the work, again, that Pat has done on this. But basically, it's doing something called named entity recognition. So these colors represent different types of entities, like green as person, and the brown as a place. And then it's actually determining relationships between those entities as well. And this is all done, again, through machine learning. I'll skip over this, but the end result is what you see here, which looks quite different from the actual obituary. So this is more structured. But this is what we call information extraction. And there are many techniques that behind information extraction, and some are more appropriate to different situations. But this is a big part of the problem too. Beyond transcription, you have to extract the information and structure it. Another just real quick demo here that's a little bit along these lines too. This is one of our BYU church service missionaries who's a grad student under Bill Barrett there. He did an experiment of actually trying to figure out the semantics of every pixel, or the meaning of every pixel on the page, in terms of whether it was handwriting, print, lines, etc. And so we call this the predator view. He actually, what was remarkable is he trained this with only a couple images, where he went through and he marked these up, and he marked the green, for example, was handwriting, and the red was print. And this, what you're looking at here, is the actual output of the network on another image, where it determined at every pixel what it thought it was. And then you can use that then to mask that original image and say, give me just the handwriting, or give me just the print text. And you can imagine how that might be useful. A lot of ways that might be useful. At the very least, it helps us separate those two different channels so that one could go through OCR and one through handwriting. But there's a lot to be done in understanding the semantics of these documents. I just wanted to give you a little taste of that. So our goal is to get to 80, but where are we going with this? And what does the future hold? And I just want to talk about just a few things that I see on the distant horizon. If we can transcribe everything we've got in these records, literally every word in these records, I think we could move towards resolving all the identities in the records. What I mean by that is, like, if there's a person in this record collection, there's a Jason Daniels over here in this record collection, and I'm picking on Jason because he's nodding off, but there's another Jason Daniels in collection B. We can say these two Jason Daniels are the same person. And there are machine learning techniques already that exist today that can help with that. In fact, we're doing this. The search team has pioneered a lot of this with the hinting that's there today, and they've been talking about doing record-to-record matching. But I believe firmly that if we can resolve all those identities in these documents that we can have some really powerful hints. And we can also figure out how big the hole in the donut is. If the tree is the donut, the records represent sometimes the hole in the donut, the people who have not been moved into the tree. We get a better sense of how big it is. But also this opens up another possibility of what are called knowledge graphs, or sometimes triple stores, where you can imagine in these records, you've got, first of all, people, those are one entities, and one triple might be person A is the son of person B. But there are other triples there too that you can think of, relationships like person A was born in the same town as person B, or person A was a witness at the marriage of person B, or person A has the same occupation as person B. And I think if we go deeper into these records than what we've indexed today, if we have the ability to basically catalog all this information, we can create some really powerful tools that help advanced researchers solve some of these brick walls. In fact, the advantage the machine has is that it can keep a lot more facts in the forefront of its memory. Even the best of genealogists that are really good at these genealogical tricks of breaking through these brick walls, as people, we're pretty finite in what we can keep in our head at once. The machine can keep a lot more in its head. Examples of this, by the way, in the industry already, like social network analysis. You're familiar with for the NSA kind of with the call log issue and the Edward Snowden thing. People freaked out that they were keeping call logs. Well, the reason they keep call logs is not that they're really interested in the fact that I called my mother-in-law. What they're interested in is I called my mother-in-law who called so-and-so who called a known terrorist. And that known terrorist is at the hub of a bunch of nodes that are suspect. So they're doing what's called social network analysis to actually try to look at the bigger topology of this network and figure out where these crime or terror networks are. Well, in a positive sense, we can do that same type of analysis on records and help people perhaps solve some mysteries in ways that people can't possibly do, even the smartest genealogists can't do. I don't know if this is making sense or not, but I feel, and Craig and I have talked about this too, that the future, once we get all this information out of the documents, is that we can analyze it in more powerful ways than what people can do and provide some really powerful hints to our patrons. And then pragmatics is just another thing that's down the road. Pat and I and the team have talked about this, but there are certain things in a document that, and I won't get into detail, but it's certain things that you can't really write rules for, like dogmatic rules, but as people, we just pick up on this. And for example, in these documents, these are burial records, and it mentions somebody who's being buried in a private grave on top of someone else who's in the grave. Pragmatically, as people, we would say, well, those two people must be related, because you wouldn't just go randomly bury someone in someone else's private grave. But that's really hard for a computer just to know that without it being taught. And there's some, I won't even get into details again, but there's some pragmatic aspects to those records. So this is a view of what's the information in those records. It never actually says that this person is the mother of this person, but if you were to read those records as a person, you would pick up on that immediately. Just the context of the situation would lead you to conclude that, yeah, she is her mother, but it doesn't say it anywhere in the record. Likewise, in that record, there's a person who's an undertaker in that record, and as people, we naturally filter that out and say, oh, undertaker is not a relevant relationship to this situation. But a computer wouldn't know that just naturally without being taught that undertaker is a kind of a low priority relationship.
Unless you're looking for him.
Unless you're looking for him, but if I'm trying to construct a GEDCOM view of that record, I don't want to probably put the undertaker in that record for this particular person. So, but anyway, these are some of the things that computers and machine learning still struggle with, kind of the more pragmatic stuff. And we foresee that we're going to need people for this for the foreseeable future. In fact, even more so in many cases. So that's all I had for the slides. What I'd like to do is turn this over now for the remainder to just do open forum Q&A. And I'll try to shut up and let the experts talk here. But it's fair game to ask about how we're doing this stuff and what our plans are. It's also fair game to talk about ideas that you might have that may, where we can counsel together and help move the ball forward.
So you're using deep neural nets is my understanding. How do you go about deciding how to structure those? How many layers to put in? How many nodes in each layer? That seems like a real art.
Yeah, so deep neural networks is an art, and so the system we have for the handwriting recognition is just one directly from the original paper where it was written. And in fact, we've talked about, do we want to extend it? There's various ways we could extend it, and so that's usually what we do is start with something and then say, what if we throw in a new convolutional neural network layer into this? Does it give us better accuracy? What does it do to our speed? So that's usually what we do is start with something and then play around with it and see if it gives us something better or something more costly. In this case, we decide on the optimal one.
Good question. Yeah.
If the secret is the data, then what can we do to learn better how to prep the data or analyze the data?
I'm going to repeat the questions too for you folks on the phone. So the question is, if the secret is in the data, what are we doing or what can we do as an organization, I'm assuming, to better prepare the data we have for machine learning? You want to field that one? I can take a first pass at it. So this one has actually been quite a journey. That you would think we just have data coming out of our ears with all the index data that we have, but there is a lot, the devil's in the detail on this. And if you just try to, first of all, we don't have the bounding boxes for the stuff that we've indexed historically. But even if we do construct those bounding boxes, but what I mean by that is the region where that text came from, it's not transcribed as it is in the document. Per instruction, we've told people to expand certain things out, like double quotes, for example. You expand those out to be the double quoted value.
Abbreviations.
And so it takes a lot of work to go through this data and scrub it so that we don't teach the machine the wrong thing. So using our stuff we've got already, it's proven to be a big challenge. And I welcome anyone who is willing to do this, to try to harvest a collection that we've already indexed and turn it into training data for us. I'm not saying it can't be done. We really love that type of help. But more importantly, moving forward, we as engineers and as product development, product managers, and operations people need to think about these projects that we're setting up and how do we capture the right information. And right now, the only way to know what that right information is to talk to people like Pat and just say, what's on your wish list for training data?
Can I comment on that too?
Yeah, go for it.
We're actually doing a project like that right now. It's a zoning project, and they're trying to zone the newspapers. So you can say, hey, here's historical newspapers. Here's the areas you're going to want to look at that have death information in them. But the guidelines were given by humans. We're originally assuming humans were going to be the ingesters of this result. And so, for example, the newspaper clippings may be too wide, or they may actually incorporate other kinds of stuff. And so one of the things we've discovered in doing this is what we really need to make sure is that when the humans are doing the original indexing or annotation or whatever they're doing, that they actually kind of know, here's how a computer is going to use this, because a lot of the things that they might do is assume that, well, you can just throw away the stuff we don't want, right? No, that's exactly the reason you're creating it to begin with, because we don't know what we want. And so I think, as John said, one of the key things is having people create data with an understanding of how a computer might use it and how a human might use it, not just so far how will humans ingest it. You have a question?
And we're going to get better at this too as an organization. There are people like Ty Davies and the Infinity team that are thinking hard about this problem.
So I'm just wondering, what are you doing to make sure you're not overfitting your training data, and what are the accuracies on non-data?
I can tell you know a little bit about machine learning. So the question is, what are we doing? What are we doing to avoid overfitting our training data? You want to field that one, or?
Yeah, I can.
Any one of you guys can jump in too if you want.
We actually have separate training and testing. And so as we train, we're running on testing data and say, we like the result here, we don't like the result there. So we don't get the overfitting problem that you might have if all you're using is the training data to train on itself.
Does that make sense?
Yeah.
In practice, we haven't seen it pop up yet, really. We haven't hit that.
But we see it in the RoboKeying processes. The system might actually train it on itself, and so we see some really good numbers. But then when we go apply them on a test set, we don't see what we hoped. But
sometimes just adjusting the neural networks, like we were talking about earlier, how it's kind of an art. We'll adjust it a certain way, and it does overfit. And so we know that, okay, we don't want to adjust it that way because it tends to overfit. So we'll pull back a little bit and try something else to do the
sorry, Al. But so people know too, overfitting refers to when it performs really well in the training data, but then when you throw it at the real, quote unquote real world data, it doesn't do so well because it's memorized the training data too much.
Sometimes you have to simplify the neural net so that it doesn't have quite as much power, so that it can't memorize the thing. It has to figure out how to find a more general solution, and that tends to work better somewhere else. Right. If you go too far, then it doesn't have enough power to
generalize.
Right?
Yeah.
So there's a balance in there.
By the way, too, I got to say, there are some really remarkable things going on in the world of deep neural networks and machine learning right now. We're really witnessing a true exciting time. And I don't want to freak people out or anything, but some people have likened it to when the jet engine was first developed. Is that once they started strapping jet engines on airplanes, there were records being broken on a weekly basis, and that's kind of my perception of what's going on in the field of deep neural networks. You can see this in the news. Things that were hard problems for so long suddenly are just like they're breaking these records week over week. So, and a manifestation of this is that speech recognition seemed like for the longest time was such a hard problem, and really expensive. But then suddenly overnight, you got these things like Siri and other solutions that just popped up, Amazon's Alexa, and the real breakthrough there was that they've got access to data and also new techniques in deep learning, and those are the same techniques that we're leveraging here.
So is all of this, or most of this work so far been in English or other languages? It seems like, obviously, the people that are working on this speak English, it's easier to have a workforce that way. It seems like the potential real leverage value would be in other languages, Spanish, and where we have perhaps a lot of records, but not a lot of people in index.
So the question is all this work being done in English? And a kind of paraphrase, you're saying, so, and why? Because if the needs are in foreign languages, why are we doing English? That's a great question. Who wants to field that? I can field it, but go ahead, Pat.
So the Wills and Deeds was chosen for a number of reasons. Did somebody else have a hand up?
Oh, no, I was thinking.
Wills and Deeds were chosen for a number of reasons. One of the things for handwriting is we didn't want to initially have to deal with the forms and so forth. We wanted prose documents because when we first started working on handwriting, that was one of the things a lot of other companies and so forth are working on. Actually, I'd say there were big boosts in handwriting recognition about 5 or 6 years ago, and the government started investing in Chinese and Arabic. But there was always prose documents, and so we thought, well, we want something prose. We want something kind of out of the way, that if we don't succeed, it didn't hurt anybody, but if we do succeed, it could potentially have a large value. So Wills and Deeds is something we haven't really indexed as a department, but if you actually look at particularly wills are sort of like, in my mind, the censuses of the 17th and 18th century. And so they were very, very valuable. But also, it's been the case that usually when you develop a new technology and you put it before people, so you say, let's suppose we did it in some other language. You say, hey, we just did this thing for you in French, and you show it to all the bigwigs, and they're going, oh yeah, we kind of get it. But when you show it in English, like he did when John did the queries there, everybody saw, yeah, we get it because it's in English, and so then they buy in. There's a lot more buy-in from upper management.
And the researchers and the people doing the annotation understand it too. That was the other practical reason.
They know what the issues are, so if it's broken, they can fix it.
But that said, prose Spanish is our top priority moving forward, and we're already starting to move into that space. And we're finding that the same techniques apply. It's just creating the training data.
So are we looking at any other partnerships in other countries like we have at BYU?
The question is, are we looking at other partnerships in other countries like we have at BYU? We've had a little interaction with academics in China.
The READ Consortium.
Yeah, the READ Consortium in EU, Germany. But in terms of universities, BYU is our flagship for sure. There is
the LDC data.
Yeah, LDC and USC. Pat has some contacts there. Their center, but BYU. The real reason that we're so closely tied to BYU is that we have people there who have the same objectives that we do. And Bill Barrett in particular has been a real driving force there. He's at a point in his career where he's really not trying to publish and make a name for himself. He just wants to crack this nut for the same reason that we do, for the redeeming of the dead. So there's just a certain level of alignment with BYU too that we just can't achieve with another university. But it's not that we haven't tried.
It just seems to me that the same way that the people in the country have a huge vested interest in getting those records available, the researchers in that country, it seems like they would have a lot at stake.
We have seen this with China quite a bit. China, I didn't get into this, but there's a lot of things about Chinese that are fundamentally different than the Latin scripts. And there are some academic groups in China that we've had contact with that are making good progress there. I won't claim that we're partnered with them the same way we were you. Yeah, Ryan.
I'm just figuring out the scale problem. Like, what I'm seeing here is a lot of very technical research from a very cracked, smart, intelligent team of engineers that are working on this, and I'm trying to get from there to how do you develop a process where you can take a new set of records, build up the training data, and do all the other testing and validate that, and get it all through in a way that you can really apply it at a larger scale. Do you have any thoughts about that?
Yeah, I think, so Ryan was asking, how do we scale this up to a real production setting from a research project? And thanks, Ryan, because that's exactly the issue that keeps me awake every night, so I appreciate you bringing that up. No, in a positive way, I'm glad that someone else feels that burden on their shoulders. And Pat feels the burden on his shoulders too, and Ty does, Ty Davies very much so, the Infinity team. But I don't have a great answer for it yet, other than that we need, at some point, this has got to graduate into a first-class engineering project. Although it's going to be a different kind of engineering project than we've ever done, because there's an ongoing research aspect to this. It's not like we just have a solution, we throw it over the wall. But we're already getting some operational experience with, I mentioned wills and deeds, for example. Pat actually is running some of this at scale, and we're finding that it's not so much, certainly not the infrastructure that's not scaling. It's the amount of prep work before you can even feed it into the recognition engine. Because these collections aren't shovel ready.
Right. Yeah, I'm just wondering how to get there.
Great question. I wish I had the answer, but we're working on it, and we could use your prayers and ideas. Al?
So I came on the research team about 5 years ago, and this was something we buzzed about getting going on. And I've watched over the past 5 years, and I've participated over the past 5 years, and I've seen the Lord's hand in a lot of things. And it seems like every time we need something, and we start urgently trying to find it and trying to find a solution for it, that the Lord presents the solution to us, or at least the next step in order to be able to get to the next point. And a big part of the collaboration that we've been doing is with the data team on the record side, and that's been a huge part of us being able to move forward and be able to scale this project from a research project to a more production project is the collaboration with other groups and the foresight that other departments have, or other engineering groups and other departments have had in noticing the problem and in feeling those urgencies from the Spirit to be able to move this project along.
So I appreciate that comment too. That data team that was Al Canaday that was speaking, that he was referring to is that Ty Davies has a team. Originally Jake set this up before Ty, but Ty Davies has further built this team within the records and partner division that really exists to support this effort. They're helping us create the training data and the test data. In fact, they currently have an effort underway to create what they're calling the 2 to 20 test set, which is a broader sampling of different languages with some additional depth in Spanish too, as I mentioned, that being a priority. But there are a lot of people behind the scenes in this effort that aren't, sometimes I fail to acknowledge. But the point is too that, I forget the point of what I was just going to say, but it is a group effort, and this is going to extend beyond already has extended beyond the research team, but will continue to do so. That's the only way that can be successful. Yeah, question on the phone.
Question from the gallery. There's a company called IntoThePast.com that was at Roots Tech. They did a demonstration to us about how the software works with indexing. They did a presentation to the church. I'd like to know how that went, what you thought about it.
What was the company again?
Into the Past.
Into the Past?
Yes, they did a presentation with 11 people from Family Church on Thursday or Friday that week. Eric Farrell.
Oh, Cardenas. Okay, got it. Yeah. So we be careful how much I say here, because we We did meet with them. I met with their CEO and their technical staff there, along with Ty and some of the partner folks, and we started a dialogue with them. All I can say is that dialogue is open, but generally speaking, the reason that it's difficult to move with these partners is that they don't understand our model or our lack of revenue that comes in as a not-for-profit, and they don't propose pricing structures that work for us. But also, it's about the training data, is that the solutions they're using, Kite Ennis, for example, which is the one you're talking about, really are the same ones that we're using. At least as much as I've assessed it so far, we're doing the same things. They may be a little bit ahead of us in some areas, but we're not too far behind them. And I've yet to see something that was like truly a breakthrough for us if we partnered with them. So, but we're looking at it too, to be clear. Yeah, Ben.
You mentioned revenue. Have we explored the value of the data that we have? It's selling to other people to research from, sponsoring contests, to leverage the community, to help us get stuff done.
Have you?
A billion images indexed with, billions of
It doesn't
fields.
seem like we've done a lot of that.
So Ben, I think your question was, could we use our image and transcription as the currency for these groups? We've tried that and it hasn't flown for some reason.
One of the really good handwriting recognition systems out there, I won't say who they are, but they came and visited with people like Rod DiGiulio and so forth, and I was in the room with them. And Rod was saying, we have all this good data. We could trade you guys for you guys to give us your system, and I know, or we have indexers who maybe there's something you guys need, and our indexers could help with that in exchange for systems. And they said no. Most of them want cash.
So, but we're not giving up on that. We're continuing to pursue that. But I will say though that we're pretty close to where they're at technically. So it's not like they're light years ahead of us either. So.
At that time we weren't, but.
So we got to close here. We got another meeting coming in. Appreciate it. If you have questions, feel free to talk to me offline or any member of the team.